Welcome students to online classes of mathematics for class 9th. In this video we are going to study chapter number 8, which is quadrilaterals of NCERT textbook, and we will be covering the remaining question of exercise 8.1. That's why I have written it part 2. Okay, this is session number 3 for this particular chapter. Myself Deepak Kodam, GD Mathematics in Kendriya Vidyalaya Sangatham. So let's start with today's class. In the previous session we have studied the question number 1 to 5 exercise 8.1. Now in this session we are going to study the remaining question, which is question 6 to 12 of exercise 8.1. Okay, let's start with the question number 6. The question is, the diagonal AC of a parallelogram ABCD bisects angle A as given in the figure. Show that the first that it bisects angle C also, and then ABCD is a rhombus. Okay, so we are given a parallelogram ABCD in which diagonal AC is bisecting angle A. That means these two angles are equal. Okay, and we have to prove that it also bisects angle C. That means these two, we have to prove that these two angles are equal. Then we have to prove that ABCD is a rhombus. Okay, so let's start. Answer number 6. First we will mention the given part. So let's try the given. Given here is answer number 6. First we will write the given part. Given here is, we are given a parallelogram ABCD in which diagonal AC is bisecting angle A. Okay, so given is a parallelogram ABCD in which diagonal AC bisects angle A. AC bisects angle A. So this is given to us. What we have to prove here is, we have to prove two things here. First one is that it also bisects angle C, and then that ABCD is a rhombus. Okay, so we have to prove two things here. First one is AC bisects angle C also, and second we have to prove that ABCD is a rhombus. Okay, so let's start its proof of part 1. Okay, so here in this question you can see that we are given this parallelogram in which we have to prove that AC is bisecting angle C also. So since it is a parallelogram, we know that in parallelogram opposite sides are equal and parallel. So we'll write, since ABCD is a parallelogram, okay, therefore its opposite side AB will be parallel to DC, and then if we are taking that these two sides are parallel, and then AC will be a transversal, and AC is a transversal. Okay, then AC will be a transversal, and we know that when a transversal intersect two parallel line, it will make two pair of alternate interior angle. Okay, so we'll get, let's name this angle as angle 1. This was 1, this is 2, then we have here 3, and angle 4. Okay, so if AB is parallel to DC and A is a transversal, so its alternate interior angle will be equal. That means this angle 3 will be equals to angle 1, and angle 2 will be equals to angle 4. Okay, so as it is, therefore AB is parallel to DC and AC is a transversal. Okay, therefore angle 1 will be equals to angle 3, and the reason why they are equal is they are alternate interior angle. Alternate interior angles. Okay, that's why angle 1 will be equals to angle 3. Okay, similarly, again taking that AB is parallel to DC and AC is a bisector, so we'll write, since AD is parallel to BC and AC is a transversal, Therefore the angle 2 will be equals to angle 4, again because they are alternate interior angles. Okay, AIA means alternate interior angles. Okay, so we got this angle 1 is equals to angle 3 and angle 2 is equals to angle 4, and question is given that this angle, this diagonal AC is bisecting angle A, that means 1 and 2 has to be equal. Okay, so we have, since AC bisects angle A, therefore angle 1 will be equals to angle 3. Okay, as it is given in the question that AC is bisecting angle A, so angle 1 will be equals to not 3, it will be equals to angle 2. Okay, so from here we got three equations. Let's name it equation number 1, equation number 2 and equation number 3. Okay, so we got three equations now. From equation 1, 2 and 3 you will get that this 1 is equals to 3 and 1 is equals to 2, 2 is equals to 4. That means this, from this equation all four angles will be equal. Okay, that means now from equation 1, 2 and 3 we get that angle 3 is also equals to angle 4. Okay, hence angle 3 and 4 are these two angles. Okay, so hence AC is bisecting, hence AC bisects angle C also. Okay, so we have proved that 1 is equals to 3 because they are alternate interior angle, and 2 is equals to 4, again they are alternate interior angle, and it's given in the question that angle A is bisected by AC, so it's two angle 1 and 2 will be equal. And from equation all three equation 1, 2, 3 we get that angle 3 will also be equals to angle 4. Okay, so 1 is equals to 2, 2 is equals to 4 and 1 is equals to 3, so they all are equal, in this, which result at that angle 3 and 4 are equals to equal, which means angle C is also bisecting AC is also bisecting angle C. Okay, that's the proof of the part 1. Now we have to prove that the ABCD is a rhombus. Now proof of the second part, that ABCD is a rhombus. Okay, so in this, so from part, okay, from above we have that angle 1 is equals to angle 2 is equals to angle 3 is equals to angle 4. Okay, that means all four angle of this given parallelogram are equal. Okay, so start now. In triangle ABC, you can see this triangle, in this triangle ABC, okay, angle 1 is equals to angle 4, angle 1 is equals to angle 4 from here. Okay, since all the angles are equal, and we have studied a isosceles theorem which says the sides opposite to the equal angle are equal. So since we know that angle 1 and angle 4 are equal, so their opposite side, these two sides has to be equal. Okay, so since we have angle 1 is equals to angle 4, this implies that their opposite side, the side opposite to angle 1 is BC and side opposite to angle 4 is AB. So this BC will be equals to AB. Okay, this is by sides opposite to equal angles is equal. Okay, the side opposite equal angles are equal. In similar way, right, similarly here in the second triangle, this angle 3 and angle 2 are equal. Okay, and their opposite side angle AD or side AD and DC will also be equal. Okay, so we'll write similarly in triangle ADC we have, in triangle ADC we have that AD is equals to DC. Okay, why? Because in that also the opposite angles These angle 2 and angle 3 are equal, so their opposite side DC and AD will also be equal. Okay, so what we got here is we got these two adjacent side AB and BC are equal, and the adjacent side AD and DC are equal. And since it's given that ABCD is a parallelogram, that means its opposite side also will be equal. So let's, since ABCD is a parallelogram, its opposite side will also be equal. Okay, therefore its side AB will be equals to CD and AD will be equals to BC, because they are the opposite sides of parallelogram. Okay, these are the opposite sides of parallelogram. So you can name them equation. We have 3 till 3 above, so let's name it equation number 4, equation number 5, and equation number 6. Okay, from equation 4, 5 and 6, from equation 4, 5 and 6, we get that all four sides are equal, that is AB is equals to BC is equals to CD is equals to DA. Hence what we got is, in parallelogram ABCD, if all four sides are equal, then it will be a rhombus. Okay, so that hence ABCD is a rhombus. Okay, and that's what we are asked to prove here, that prove that ABCD is a rhombus. So what we did here is we proved that all four sides are equal. First we proved that by the angle, if the opposite angle, the side opposite angle are equal, similarly the side opposite angle are equal. So we got two pair of adjacent side equal, and since ABCD is a parallelogram, so its opposite side has to be equal. So from equation 4, 5 and 6 we got all four sides of this parallelogram are equal, hence ABCD is a rhombus. Okay, now moving to the next question, question number 7 we have here is, ABCD is a rhombus, show that the diagonal AC bisect angle A as well as angle C, and diagonal BD bisect angle B as well as angle D. Okay, so we have to prove two things here. So first we'll write the given part. This is answer number 7. First we'll write the given portion. Given here is again a rhombus ABCD. So given is a rhombus ABCD, ABCD, in which we have to prove, so there is nothing else given, directly we are asked to show that. So we'll write to prove is, we have to prove two things here. First, they show that the diagonal AC bisect angle A as well as angle C. That first is AC bisects angle A as well as angle C, and second we have to prove that diagonal BD is bisect angle B as well as angle D. Okay, BD bisects angle B as well as angle D. Okay, so these two things we have to prove here. So let's start its proof now. We'll prove only the first part, and in similar way we can prove the second part. So we are going to show the proof of the only first part, and then we can write similarly we can prove the other part. Okay, when we have to prove two same thing, then we will prove only the first one and we'll just write similarly the other part. Okay, like we are going to do here is, so since we have to prove that this AC is bisecting angle A, this here, and also angle C. Okay, so we have to prove that the angle these two are equal, similarly these angles are equal. That's what we have to prove. Okay, and we have to prove it in other way also for angle B and D. Okay, so let's start. In triangle, this is part 1. In triangle ADC, so we are taking this triangle. In triangle ADC, we have that AD equals to, right, we have side AD will be equals to side DC. Okay, why they are equal? Because the given figure is a rhombus, and a rhombus all four sides are equal. So we'll write equal sides of rhombus. Okay, so that's why AD and DC are equal. So if these sides are equal, then their opposite angle has to be equal. So we have studied the theorem in chapter 7, which is as well as Isosceles Theorem. It says the angles opposite to the equal sides are equal. So if these sides are equal, their opposite angle, the angle opposite to AD, this side is angle DCA. That means angle DCA will be equals to its this angle opposite to DC is angle DAC. Okay, angle DAC, these two angles will be equal. The reason is these angles opposite to equal side of a triangle are equal. Okay, the angle opposite to the equal side of a triangle are equal. That's why we got these two angles equal. Okay, now since this AB and DC are parallel and AC is a transversal, so their alternate interior angle will be equal. Okay, so we'll write since AB is parallel to DC, AB is parallel to DC, okay, and AC is a transversal. Okay, so therefore its alternate interior angle DCA and BCA and DAC angle, this one BCA and DAC will be equal. Okay, so we'll write angle BCA will be equals to angle DCA. Okay, sorry, BAC, not DCA. BCA will be equals to angle DAC. Okay, so suppose this was the equation number 1, this is equation 2. Okay, reason for this one is alternate interior angles. Okay, so we got that DCA equals to DAC and BCA equals to also DAC, and this will give us that both are equal to DAC. So this DCA and BCA will be equal. This DCA is this one angle and BCA is this one. That means AC is bisecting angle A. Okay, so we'll write from equation 1 and 2. From equation 1 and 2 we get, so both we have DAC and DAC and they are equal to DCA and BCA. So from equation 1 and 2 we get that BCA, angle BCA is equals to angle DCA, hence AC bisects angle C. Okay, so this AC is bisecting angle C. Now we have to prove that AC is also bisecting angle A. So we'll write now in triangle ABC. Now we are getting this lower triangle, this one ABC. Okay, in triangle ABC we have, in similar way, the side AB is equals to BC because they are the sides of a rhombus. Okay, sides of rhombus, that's why they are equal. We know that in a rhombus all four sides are equal. Okay, and the reason why they are equal is they are the sides of a rhombus. Okay, that's why these two sides are equal. Now we'll use the isosceles theorem, which says these angles opposite to the equal sides are equal. So okay, in a triangle the angle opposite to equal sides are equal. So angle opposite to side AB is this BCA and the angle opposite to side BC is angle BAC. So angle opposite to AB is, so side AB is BCA, therefore angle BCA will be equals to angle BAC. Okay, reason for this one is angles opposite to equal sides of a triangle is equal. So the angle opposite the equal side of a triangle is equal. Okay, and also, all right, since or we can write that in the above equation we have proved that BCA is equals to DAC. In equation number 2 you can see here in this one that BCA is equals to DAC here, and here we prove that BCA is equals to BAC. So we can write, let's name it equation number 3 first. Okay, let's name this as equation number 3. Now we'll write from equation 2 and equation 3 we get, from equation 2 and equation 3 we get, what we get is that both are equals to BCA and BCA are here equals to DCA and BAC, DAC and BAC. So from equation 2 and equation 3 we get angle BAC is equals to angle DAC. Hence AC bisects angle A also. Okay, so here we prove that AC is bisecting angle C, and here we prove that AC bisects angle A also. So instead of solving this now second part that BD is bisecting angle B and D, we'll directly just write similarly diagonal BD so we'll write similarly diagonal BD bisects angle B as well as angle D. Okay, so we are not going to show this second part, proof of the second part, because we can prove this in the similar way like we did in the case of AC bisecting angle A and as well as angle C. Okay, so we just write similarly diagonal BD bisect angle B and angle D. Okay, we will not going to show the proof of that because the method is exactly similar. So every time when you have the same two things to be proved, then we'll prove just one and then try the similarly we can prove the other one. Okay, like I have written here similarly diagonal BD bisect angle P and as well as angle D. Okay, so that's the solution of question number 7. Now moving to the next question. Question number 8 is ABCD is a rectangle in which diagonal AC bisect angle A as well as angle C. So we are given a ABCD rectangle. Okay, so what given here is ABCD is a rectangle in which AC bisect angle A as well as angle C. We have to show that ABCD is a square and the diagonal BD bisect angle B and D as well. Okay, so in the last three in all three question 6, 7 and 8 we are proving that the diagonal of this quadrilateral, which is whether a square, a rectangle or a parallelogram, diagonal is bisecting the angles. Okay, that's AC is bisecting angle A and angle C. Then similarly when you draw the BD, that will bisect angle B and angle D. Okay, now let's start the answer number 8. The given here is a rectangle ABCD, a rectangle ABCD in which AC bisects angle A as well as angle C. Okay, this is given to us. We have to prove two things to prove is, first is we have to prove that ABCD is a square. Second, we have to prove that diagonal BD bisects angle B as well as angle D. Okay, here I have to prove two things. First is that ABCD is a rhombus, or sorry, ABCD is a square. Okay, while we are given that ABCD is a rectangle, we have to prove that ABCD is a square. Then we have to prove that diagonal BD is bisecting angle B as well as angle D. Okay, let's start its proof now. So we are going to start this proof now. Proof point 1, what we have to prove here is that we need to prove that ABCD is a square, while we are given that ABCD is a rectangle. Okay, so we have to prove ABCD is a square while ABCD is given as rectangle, and we know that in a square and a rectangle all the angles are of 90 degree. Only thing that is different from square and rectangle is that in a square all the four sides are equal, while in rectangle opposite sides are equal. So if you prove that the any one pair of adjacent side in the rectangle is equal, then it will be a square. Okay, so if you prove any one pair of adjacent side of this rectangle is equal, then it will be a square. So let's start. In rectangle ABCD, we have angle A is equals to angle B, will be equals to angle C, will be equals to angle D, and each will be of 90 degree. Okay, so as we know, in the rectangle all the four angles are equal and each will be of 90 degree. Okay, so from here we can write angle A is equals to angle C. So what we got is angle A is equals to angle C, and in the question is given that diagonal AC is bisecting A and as well as angle C. Okay, so what I have written here is that since AC is bisecting angle A and angle C, so I have marked this as angle 1, angle 2, angle 4 and angle 3. Okay, so as AC bisect angle A, that means this angle 1 and 2 will be equal, and this 3 and 4 has to be equal. Okay, so we'll write, since diagonal AC bisects angle A and angle C, therefore the angle 1 and 2 will be equal. Angle 1 will be equals to angle 2, and angle 4 will be equals to angle 3. Okay, and they are the half of the angle. These are the half of angle A and these are the half of angle C, or we can write this implies that the all four angles will be equal. That is, angle 1 is equals to angle 2 is equals to angle 3 is equals to angle 4. Why they are equal? Because they are the half of the equal angle. Okay, we have angle A equals to angle C, and they are the half of the equal angle, and that each will be of 45 degree. Okay, so as these angle are 90 degrees, so their half will be 45 degrees. So angle 1 is equals to angle 2 equals to angle 3 equals to angle 4. From here we can write, or we'll take that these two angle 1 is equals to angle 3. Okay, angle 1 is equals to angle 3. Okay, now you will see that in triangle ABC, since these two angle 1 and 3 are equal, in using the isosceles triangle property, that the sides opposite to the equal angles are equal. Okay, so if we have these two equal angle, so right, in triangle we have this triangle ABC. In triangle ABC, side AB will be equals to side BC. Okay, so reason for this one is sides opposite to the equal angles is equal. Okay, the side opposite to equal angle is equal. So what we got is side AB is equals to side BC, and from the rectangle we have that the all four opposite sides are equal. Okay, since ABCD is a rectangle, therefore its opposite side has to be equal. That means side AB will be equals to its opposite side CD. Okay, AB will be equals to CD, and AD will be equals to BC. Let's name them equation number 1 here, equation number 2, and equation number 3. Okay, so from equation 1, 2 and 3 we get, from equation 1, 2 and 3, we get the all four sides are equal. That means AB is equals to BC is equals to CD is equals to DA. Hence ABCD is a square. Okay, since we have proved that its all four sides are equal and we already have its all four angle equals 90 degrees, that means ABCD will be a square. Okay, next we have to prove that diagonal BD bisect angle B and angle D. Okay, so we know that in a square the diagonals bisect the angles. Okay, so we try it directly. This is part second. Since ABCD is a square and we know that the diagonals of a square bisect the angles, that the diagonals of a square bisect the angles. Okay, that is BD bisects angle B as well as angle D. Okay, so we'll directly write, we know that these since ABCD is square and we know that the diagonal of a square bisect the angle, that is BD will bisect angle B and as well as angle D. Okay, directly using the property. Okay, so that's the answer of question number 8. Now moving to the next question, question number 9. It says in parallelogram ABCD 2 points P and Q are taken on diagonal BD such that, so we have a parallelogram ABCD in which P and Q, which are these point, okay, which taken on diagonal BD such that DP is equals to BQ. So we have this DP is equals to BQ and ABCD is a parallelogram. So here we have to prove 5 things. First, that triangle APD is congruent to CQB. Second, then AP equals to CQ. Then third, triangle AQB is congruent to triangle CPD. Then AQ is equals to CP, and then lastly we have to prove that APCQ is a parallelogram. Okay, so let's start its answer number 9. Okay, first we will write all the given information. Given here is we have a parallelogram ABCD, a parallelogram ABCD in which 2 points P and Q are on diagonal BD such that DP is equals to BQ. So this is what given to us. Now let's write its proof. We have to prove here, we have to prove total 5 things. First one here is that triangle APD is congruent to triangle CQB. Second, we have to prove that AP is equals to CQ. Third, we have to prove that triangle AQB is congruent to triangle CPD. Okay, next we have to prove that AQ is equals to CP, and the lastly we have to prove that APCQ is a parallelogram. Okay, so let's start one by one. Proof of part 1. Okay, so first we have to prove that triangle APD and CQB are congruent. So first locate the triangles. So this APD is this one and with CQB is this one. Okay, so we have to prove these two triangles are congruent. We can simply prove that since ABCD is a parallelogram, so its opposite side AD and BC will be equal. Okay, so we got one side, and then this AD and BC are parallel. Okay, these two sides are parallel. So and BD is a transversal, so their alternate interior angle will be equal, these two angle. Okay, so we got one side and one angle, and in the question is given that this DP is equals to BQ. That means this DP and BQ are equal. That means this angle side angle side, these two triangle will be congruent. Okay, so we'll write in triangle APD and triangle CQB, we have that side AD is equals to BC, AD is equals to BC. So we'll write opposite sides of parallelogram, opposite sides of parallelogram. Okay, next we'll write since ABCD is a parallelogram, since next we'll write since ABCD is a parallelogram, okay, in which this side AD is parallel to BC and BD is transversal. Okay, therefore the angle will take this AD till point B. Okay, ADB will be equals to angle ADB will be equals to angle CBD. Okay, they are the alternate interior angles. Okay, or we can write this as, instead of taking this DB completely, okay, let's erase this first. Instead of taking this DB completely, we'll take it only till point P. Okay, so we can write this angle ADB as angle ADP. In similar way, we can write this angle CB. Instead of writing it till point D, we'll write it only till point Q. Okay, again this is our alternate interior angle. So we got one side and the one angle here. Now we can write, and we have that in the question given that DP is equals to BQ. So in question we have DP is equals to BQ. Okay, so what we got here is we got one side, one angle and another side. Okay, so we'll write therefore triangle APD is congruent to triangle CQB, and this is by side angle side congruence rule, side angle side congruence rule. Okay, so that's the solution of part 1. Now come to the second one. We have to prove that AP is equals to CQ. Since we have proved that these two triangles are congruent, okay, then their corresponding part, this AP, this one will be equals to CQ, okay, by CPCT. Okay, so we'll write since triangle APD is congruent to triangle CQB, therefore the side AP will be equals to CQ. This is by CPCT. Okay, that's the proof of part second. Now come to the third one we have here. Now we have to prove that the triangle AQB is now this one, AQB and CPD, these two triangles. We have to prove that. Again in similar way we are going to prove this. The opposite side is AB and CD will be equal because they are the opposite side of parallelogram ABCD. Then this side BQ and DP are already given equal, so we got two side and then included angle. These will be equal because AB and CD are parallel and BD is a transversal, so they are alternate interior angle. So we'll write in triangle AQB and triangle CPD, we have the side AB is equal to side CD, which are opposite sides of parallelogram. Okay, that's why these two are equal. After that we have, since ABCD is a parallelogram in which AB is parallel to CD and BD is transversal. Therefore the angle again ABQ will be equals to angle CDP. Angle ABQ will be equals to angle CDP, because they are alternate interior angles. Okay, so we got a side here, an angle, and we have, all right, and we are given that this side DP is equals to BQ. So right, BQ is equals to DP. This is given, and we got this another side now. So right, therefore triangle AQB is congruent to triangle CPD, and that too by side angle side congruence rule. Okay, so we got these two triangle congruent. Okay, now come to the part 4. Here we have to prove that this AQ is equal to CP. So right, since triangle AQB is congruent to triangle CPD, therefore their corresponding side AQ will be equals to CP, and that too by property CP/CD, that is corresponding part of congruent triangle are equal. Okay, now come to the last part of this question on part 5. So in part 5, so we have in quadrilateral APCQ, in quadrilateral APCQ, since opposite sides are equal, opposite side we have proved that AP equals to CQ, and the above we have proved that AQ is equals to CP. Okay, therefore APCQ is a parallelogram. Okay, so that's the solution of question number 9 of exercise 8.2. Now moving to the next question number 10 is, in ABCD is a parallelogram and AP and CQ are the perpendicular from the vertices A and C on the diagonal BD, so that you have to prove that the two triangles are APB and CQD are congruent, then AP equals to CQ. This is very simple. Here we have this parallelogram ABCD in which AP and CQ, this AP and CQ are the two perpendicular from the vertex A and C, okay, to the diagonal BD. Okay, and we have to prove that AP and CQ are equal. Okay, so what we are going to do is, since they are the perpendicular, so the angle here will be 90 degree and 90 degree. So we got one angle. Since in the parallelogram CD and AB are parallel, so their alternate interior angle, these two angles will be equal. Okay, and this side DP and AB will be equal. So we got angle side. Similarly, angle side. So by AAS congruence rule, these two triangles will be proved congruent. Okay, so let's start by writing its given part. So first write answer number 10. We'll mention the first given. given here is a parallelogram ABCD, a parallelogram ABCD in which AP and CQ are perpendiculars from A and C respectively, A and C on diagonal BD. Okay, we have to prove two things here. First one is, first we have to prove that the triangle APD is congruent to triangle CQD. Okay, this APB. And second, we have to prove that AP is equals to CQ. Okay, so let's start its proof. So first we'll write in triangle APB, and triangle CQD, we have, what we have here is that the angle APB is equals to angle CQD. Angle APB is equals to angle CQD, and each of 90 degree. Okay, because we are given that the AP and CQ are the perpendicular. So we got one angle. Then we have, since ABCD is a parallelogram in which the opposite side AB is parallel to, in which AB is parallel to CD, and this BD is a transversal, and BD is a transversal. Therefore angle, so we have the angle ABP, angle ABP will be equals to angle CDQ. Okay, will be equals to angle CDQ, and because they are alternate interior angle, ABQ and CDPQ, sorry, ABP and CDQ. So these two angles are equal because they are alternate interior angle. So we got one angle here, another angle here, and we have also side AB is equals to CD because they are the opposite sides of parallelogram. Okay, so we got now a side. So by angle side congruence rule, these two triangles will be congruent. So right, therefore triangle APB is congruent to triangle CQD, and that too by angle side congruence rule. Okay, now come to the second part. We have to prove that AP equals to CQ. Second part is, since triangle APB is congruent to triangle CQD, that is proved in the part 1, therefore AP will be equals to CQ, and that too by property CP/CT, that is corresponding part of congruent triangle are equal. So that's the solution of question number 10. Now moving to the question number 11, we have in the figure triangle ABC and DEF. So we have two triangle ABC and DEF. In this, AB is equals to DE. This side AB is equals to DE, and also AB is parallel to DE. So these two are also equal and parallel. Similarly, BC and EF are equal and parallel. This side BC and EF are also equal and parallel, and vertices A, B, C are joined to vertices D, E, F respectively. So all the vertices A is joined to D, C is joined to F, and B is joined to E. Okay, so now we have to prove here total 6 things. First one is that AB ABED is a parallelogram. Okay, so we'll start one by one. First, write the answer number 11. Okay, we'll write the given here is two triangle ABC and DEF, two triangles ABC and DEF in which AB is equals to DE and AB is parallel to DE. Okay, and we have one more thing, that BC is equals to EF and BC is parallel to EF. So we got two sides, two different pair of sides are equal and parallel. Then vertices A, B, C and join to D, E, F, and vertices A, B and C are joined to D, E and F respectively. Okay, so these are the given information. We have to prove total 6 things here. So let's try to prove is, first we have to prove that ABED is parallelogram. Okay, second we have to prove that BEFC is also a parallelogram. Then third we have to prove that AD is parallel to CF, also AD is equals to CF. Then we have to prove part 4 that ACFD is a parallelogram. ACFD is a parallelogram. In part 5 we have to prove that AC is equals to DF, and lastly we have to prove that triangle ABC is congruent to triangle DEF. Okay, so let's start the proof of each one by one. First one is, we have to prove that the ABED is a parallelogram. So write, in quadrilateral ABED we have, in quadrilateral ABED we have that side AB is equals to DE, AB is equals to DE and AB is parallel to DE. So right, since we know that, okay, so what we got here is, in the in quadrilateral ABED we got one pair of opposite side is equal and parallel. So by theorem 8.8 which says, if in a quadrilateral one pair of opposite side is equal and parallel, that it will be a parallelogram. So we write, since we know that if in a quadrilateral one pair of opposite side is equal and parallel, then it is a parallelogram. Okay, that is, or you can write, hence ABED is parallelogram. Okay, so simply, since we are given that one pair of opposite side is equal and parallel, so using theorem 8.8 we can say that ABED is a parallelogram. Okay, in similar way we have the part second. Now we have to prove that BEFC is a parallelogram. So we have, in quadrilateral we have second quadrilateral is BEFC. Okay, in quadrilateral BEFC we are given that BC is equals to, so right, we are already given that BC is equals to EF and BC is parallel to EF. So right, as we know that if in a parallelogram, if in a quadrilateral, one pair of opposite sides is equal and parallel, then it is a parallelogram. Okay, hence BEFC is a parallelogram. That too by using theorem 8.8 directly. Okay, now let's come to the part 3. Here we have to prove that in part 3 that AD is parallel to CF. We have to prove that this AD is parallel to CF and AD is equal to CF. So since we have already proved that the above two are the parallelogram, that is ABED is parallelogram, and we have proved that BEFC is a parallelogram. So from here we'll get that now we have that AD is equals to BE and AD is parallel to BE. Reason for this one is since ABED is a parallelogram, and we also have that CF is equals to BE and CF is also parallel to BE. This is why since BEFC is a parallelogram. Okay, so what we got here is now that AD is equals to EBE and CF is equals to BE. That means these AD and CF also be equal. Okay, similarly this AD is parallel to BE and CF is also parallel to BE, then AD and CF will also be parallel. So right, from, let's name it equation number 1 here and equation 2. So we'll write from equation 1 and 2 we get, from equation 1 and equation 2 we get, what we get is that AD is equals to CF and AD is parallel to CF. Okay, that's what we are asked to prove in the part 2nd. Now let's see part 4. Here we have that we have to prove here that in part 4 that AB quadrilateral ACFD is a parallelogram. Okay, so we'll write since AD is equals to CF and AD is parallel to CF, that is, this implies ACFD is a parallelogram. Okay, the reason for this one is one pair of opposite side is equal and parallel. One pair of opposite side is equal and parallel. Okay, so if any quadrilateral you find the one pair of opposite side is equal and parallel, then it will be a parallelogram. Okay, now let's come to the part 5 of this question. Here we have to prove that AC is equal to CF. So simply, since we have proved that ACFD is a parallelogram, since ACFD is a parallelogram, Therefore its opposite side AC will be equals to DF. Okay, reason for this one is opposite side of parallelogram. Opposite sides of parallelogram. Okay, now let's see the last part of this question. You have to prove that triangle ABC is congruent to triangle DEF. We have to prove that triangle ABC is congruent to triangle DEF. So write in triangle ABC and triangle DEF, we have what we have is that AB equals to DE. This is as okay. These are the let's write this opposite sides of parallelogram. These are the opposite side of parallelogram AB ED. Okay, and we have that BC is equals to EF. Again, this is opposite sides of parallelogram. This time we are taking parallelogram BEFC. Okay, then we have next, and CA is equals to FD, and these are because opposite side of parallelogram ACFD. Okay, so we got three pair of side equal. This is one side, second and third, and because these are the opposite side of the parallelogram ABED, BEFC and ACFD. Okay, therefore triangle ABC is congruent to triangle DEF by side congruence rule. Okay, so that's the answer of question number 11 of exercise 8.1. Now come to the last question of this exercise. We have the question number 12, which says in ABCD is a trapezium in which AB is parallel to CD and AD is equals to BC. So we have two sides parallel, that AB. Firstly, we have this trapezium ABCD in which one pair of side AB and CD are parallel, and we have the non-parallel side which is AD and BC are equal. So these two sides are equal and these are the parallel. Okay, here we have to prove four things. First is that AB is equals to angle A is equals to angle B, angle C, second angle C is equals to angle D. Third, we have to prove that triangle ABC is congruent to triangle BAD. Then diagonal AC equals to diagonal BD. Okay, so first we'll start with the construction. So first we'll write let's write the answer number 12. First we'll mention the given part. Given here is a trapezium ABCD in which we have this AB is parallel to CD. Like we know in a trapezium one pair of opposite side has to be parallel, and the non-parallel side which is AD is equals to BC. That means it is an isosceles trapezium. Okay, and we have to prove four things here to prove. First we have to prove that angle A is equals to angle B. Secondly, we have to prove that angle C is equals to angle D, and then we have to prove in part third that triangle ABC is congruent to triangle BAD, and the last one we have to prove that diagonal AC is equals to diagonal BD. Okay, so first we'll start with the construction. Let's write construction. So what we are going to construct is we'll produce the side BA till point E such that AD is parallel to CE. Okay, so we'll write produce AB such that CE is parallel to AD. Okay, so we'll extend this line till point E such that this CE will be parallel to AD. Okay, that's what we are doing construction here. Okay, so now let's start its proof now. Also what we're going to do is we'll draw its two diagonal, okay, AC and BD. Let's draw the diagonal, this BD, and we have a diagonal AC. Okay, so these are the two diagonal of this trapezium ABCD. Here we have to prove that the angle A is equals to angle B. Okay, so let's start this proof now. Since AD is parallel to CE and AE is a transversal. Okay, as you can see, we have this AD is parallel to CE, and to them this AE is a transversal. Therefore we have that sum of angle A plus angle E will be equals to 180 degree. And reason for this one is this: the angles on the same side of transversal is supplementary. Okay, the angles on same side of transversal are supplementary. Okay, the angles on the same side of transversal are supplementary. That's why this two angle will be equals to 180 degree. Okay, so we have, since AB is parallel to CD and AD is parallel to CE, therefore we have that AD is equals to CE, and this implies that BC will also be equals to CE. Okay, like you have that it's given in the question that these two sides are equal, and by construction we have drawn that these two are equal. So by default these BC and CE will be equal. Okay, BC and CE will also be equal. Since reason for this one is since we have that AD equals to BC, which is given. Okay, so now in triangle BCE, which is this triangle. Okay, in this triangle the sum of the two angle, that is in triangle BCE, we have that BC will be equals to CE, but as we have this here. Okay, so as these two sides are equal, so their opposite angle will also be equal. Therefore their opposite angle, that are the angle CBE, will be equals to angle CBE. So we have CBE will be equals to CEB. Okay, and that will be, this implies that this we can write this CBE as 180 minus angle B. We can write this as 180 minus angle B, and at the place of angle CE we'll use the angle E. Okay, so 180 minus angle B is equals to angle E, or we can write this from here that we have this angle E here, and also we have the value of angle E here. Let's name it equation number 1 and this equation number 2. So we'll write from equation 1 and 2. From equation 1 and equation 2 we get, what we get is, at the place of this angle E we will use this value, that is E equals to 180 minus angle B. Okay, so in equation 1 we have that angle A, and at the place of angle E we'll write 180 degree minus angle B equals to, there we have 180. Okay, so these two 180 will be cancelled out. What remains is this A minus angle B equal to 0. Okay, so when you shift this minus B onto the right hand side, will be angle A equals to angle B, and that's what we were asked to prove in the part 1, that angle A equals to angle B. Okay, so we have proved the part 1. Now we have to prove that angle C is equals to angle D. Okay, so we'll write, second is, since angle A equals to angle B. Okay, we have proved that in the figure that angle A and angle B are equal. Okay, and we know that, okay, this will implies that their the side, that is angle B, and we can write this angle A as angle BAD equals to angle ABD, which are using the side of the trapezium. Okay, we can write this BAD as 180 degree minus BAD, and similarly 180 degree minus angle ABD. Okay, we have subtracted both the angle from 180, so this will not change the value. Okay, subtracting both the angle from 180, so this will 180 minus angle BAD equals to 180 minus angle ABD. Okay, so 180 minus BAD will give us the angle ADB, and 180 minus angle ABD will give us angle BCD, which means angle angle D is equals to angle C. Okay, and that's what we are asked to prove here. Okay, so that's the proof of the part second, that angle D is equals to angle C. Next is the part third. We have here now that in triangle, we have to prove here that triangle ABS is congruent triangle BAD. So we'll write in triangle ABC and triangle BAD, we have what we have is that the BC is equals to AD, which is given. Okay, and we have that AB is equals to AB, which is common for both the triangle, and we have the one angle, that angle A equals to angle B. So we have proved in one. Okay, proved, you can write proved above, or you can prove in part 1. Okay, so we got the angle, side angle. So by SAS criteria, these two triangles will be congruent. So therefore triangle ABC is congruent to triangle BAD, and that too by side congruence rule. Okay, so we got two triangles congruent. Now part 4 is we have to prove that AC equals to BD. Okay, so similarly we have that since triangle ABC is congruent to triangle BAD, therefore the AC will be equals to BD, and that's by CPCD, that is corresponding part of congruent triangle are equal. Okay, so that's the part 4 of question number 12. With this we have concluded all the question of exercise 8.1. okay, I hope you understood all the question. You have to practice all this question multiple times, only then you will be able to understand this question better. Okay, because these questions required practice. Okay, so try to understand this very well. If you have any problem, you can contact me. Okay.